All right, welcome back to another video from the Clark and Addison Gaming Company. My name is Brian Hafferkamp. I'm the designer and creator here at Clark and Addison. And in this video, we're going to continue going through how I created a game, a tabletop baseball game using ChatGPT, so generative AI, and my spreadsheets as well. So we're going to continue on. You can see here I'm about, what is that, about a quarter of a way, a quarter to a third of the way through everything I used for this initial chat here. So you can see I've included some other chats as we go along. I'm trying to do a better job of sort of utilizing this project structure. So I don't think I really covered this very well in the first one, and we'll get to it at the very end of this chat. But I was asking ChatGPT, like, how can I speed up the chats? The longer they go, the slower they get, right? So it's like going through more data. It has to like process that every time it opens it, etc. So it was telling me about projects, and I said, okay, I can see where that would be helpful to put those things into a folder structure so I can just easily get to those chats rather than having to scroll through them on the left side. But I said, if I put the chats into the projects, will they be self-referential? So will you be able to reference each of the chats inside the project? And it affirmed and said yes. So really, that's what I want. I want to be able to have multiple, I want to start a new conversation around a new topic that's a smaller topic, but I still want it to be able to reference everything that we've been talking about the whole time. So I'm super stoked about that. So I can put all of my chats about a game into the folder, the project folder. And when like this if statements or the fielding loop, it's going to reference all of the things we've been talking about in this chat, in this chat, in this chat. So they're all contained within that project structure. Now, I don't know how long they're going to go before they realize this is a workaround for not having the paid or whatever. But for now, you can use the projects, and then all of the chats in here are able to reference one another. So that's a game changer for me, because now I can, instead of doing one huge chat, because that's why I've been doing long chats, is because I need it to be able to reference everything that we had at the beginning of the conversation or what we've been talking about all along. But here I can have smaller chunks of chats, which makes everything go super fast. But it still self-references the conversation and all the different things that we've been talking about. So that's a little, that's my best trick of the day. So let's continue forward. If you watch the other video all the way to the end, I'm very sorry, because on OBS, if you type in M like this, so if I type in M, it goes to mute. Somewhere along the way, I typed in M, and I was doing something with the search at the very end of the last video, and I typed Arizona Diamondbacks, and as soon as I hit the M, it muted it. So I'm really sorry about that. So I'm just going to recover. In the first video, we talked about the initial chat, the initial interaction between the batter and the pitcher. At the very beginning of this, I wanted it to be just about the pitcher, right? So it was sort of the PV rating idea from Status Pro. Now I feel confident that we have the spreadsheet set up. So if we go to our pitcher combined, you can see the spreadsheet, and I'm not going to harp on this or dwell on it a lot, but you can, this is Zach Gallen, Brandon Pfaadt. These are the pitchers. And so now we have all of our BABIP, ground ball, fly ball, line drive percentages for righties and lefties. We have all of our homemade home run K and walk percentages, as well as the ball in play percentage. We've converted that over to this Not efficiency. That's the first number that comes to mind. That's the first thing that comes to mind, but it's not. It's basically comparing this person against the league average. So balls in play against the league average. So then we use all that data to create the number of slots for each card. So each card needs to have, let's see if we can pull it up. All right. Sorry, I hit a couple of buttons there just to make sure everything's okay. So each of these slots, we have 36 slots. So 11 to 66, just as a refresher. The black are the ones you use against a left-handed batter. The red are the ones you use against right-handed batters. So we have 36 slots. So in here, we need our home runs, Ks, walks, and contact. This is things like ground balls, fly balls, line drives. We need all this to equal 36. So 24 plus 7 is plus 3 is 27, plus 9 is 36, right? And so that needs to be the same for everybody across the board. And we use home run percentage to figure out how many slots need to be taken up for home runs, K percentage to figure out K slots, walk percentage to figure out walk slots. So you can essentially just look at this and say he strikes out a lot more than he walks. So it's like a more than 2-to-1 ratio. Here, even better. Here, a little bit worse. Here, a lot worse. So, but here, high strikeouts, low walks, right? High strikeouts, low walks, same here. And this is 50, about twice as much. Here we have more walks than strikeouts. That's not good. And this guy gives up more home runs at about almost 3% more home runs than anybody else. I don't know who that is, but you can really see each player here. These are very high strikeout pitchers. So these three here, this guy's at 11. This guy's at 12. Who is that? Taylor Rashi and Justin Martinez. Martinez had a really good year as a reliever. Okay, so then we take these 36 slots, and then we need to assign ground balls, fly balls, and line drives to these contact slots. So that becomes our, where you see GB, LD, FB, those are our contact slots. So then we use the contact slots and we break that down. These are just going to stay what they are. And we break these down into right-handed and left-handed. And then we need to figure out of this 24, how many are going to be ground balls, fly balls, and line drives. Now we get that from our percentages here, right? They've given up a certain percentage of ground balls, fly balls, and line drives against lefties and righties. So we just multiply that the ground ball percentage against right-handers with the slots, right? So that's I'm in Pew only. Let me get out of that. Let me get into the one where we can actually click around a little bit. Sorry, it's going to take a minute. So pitcher data combined. This is just my main data sheet that brings together all of the little pieces of data into the same sheet. And then off of this one, we create the pitcher cards. So that's the workflow that I have. So here now we can see AR3 is this one. So contact slots times right-handed ground ball percentage, right? And then we round that up. And so we do the same thing for each of these for right-handed batters, then for left-handed batters. So every pitcher has right-handed and left-handed. And then we do the same thing when we come to this section here. This one is all about taking these ground ball slots and breaking those up between ground ball hits and ground ball outs. So then we need to use the batting average on balls in play, because these contact slots are all the balls in play. So then we need to figure out the average on balls in play. We use that I know that's not technically it, because this home run over here is also sort of technically included. It'll be a little bit inflated maybe, but I think it's so small that it's not going to be that big a deal. It hasn't felt like it's that big a deal. So that's kind of where we're going with that. So against right-handers, ground ball hits and ground ball outs. So out of this 11 against right-handers, how many were hits and how many were outs? And then we just basically take this, the ground ball slots, and then we multiply it by the batting average on balls in play against right-handers. And then we do that for against lefties. We do it for fly ball hits. We do it for fly ball hits with both, and then we do line drive hits. So the same. So basically we're multiplying these numbers by the batting average on balls in play, and that gives us our hits for each of these. And then the outs are simply going to be what's left over. So we just take this 11, we subtract it from the number of hits, and then whatever's left over is going to be our outs structure. So that one's super easy. We do that all the way along for all of these, and that's going to, remember, these represent slots on the card, right? It represents each of these results. So don't want to belabor that too much, but then we come here and we look at all of these slots, and then we assign those slots. We take it from a number and we assign it some sort of string, some sort of text, right? And so we have one home run slot, and you can see there's one home run. If I span this out, you can see the whole thing. We have 8 strikeout slots, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 2, 3 walk slots. And then we look at singles. Those are the 3 ground ball hit singles. And then we have ground ball outs, or ground balls that are potential outs, more than likely. We have fly ball singles. These are like little dinks and dumps into the outfield. Then we have fly balls, which can turn into outs. And then for the line drive hits, those are doubles. So you can see here, if it's a line drive hit, what is that? BG3. So sorry, it's going to cover over it. If it's BG3, the line drive hits are going to turn into a double right here. And then otherwise, the line drive outs are just going to turn into a line drive. And those act, for the most part, like fly ball. So that's how that section works. And then once we convert that to those letters, what I do is I come through here and I make sure that these things, I count the numbers here. I want to count these and make sure that they are 36. And if they're not 36, then it should go yellow. So it tells me right offhand which ones are spot on. There's 36 results because that's all that we need. If we get more or less, it's not going to cover all of our stuff here. And if we get more, it's not going to give us the percentages that we need because we worked everything off of 36, 1 to 36, right? Or 36 slots. So it gives me a yellow. And then the way I've gotten around that, at least on the batter side, is I've gone through and created a secondary result here. I just did it the other day. I created a secondary column that checks what is the offset of the 36. So if you look here, I created this offset column. So originally this one had 37. So then I say 36, and I don't do it here because I have to copy all this down, but basically 36 minus whatever this results count is of all these. 36 minus that, and it gives me this sort of remainder column here. And then it won't let me leave it as a formula, so I have to actually like copy and paste it down so that it's just actual numbers. You can see up here, it's like actual numbers. And then I take that offset and I ask the ChatGPT, I was like, where should I adjust these so that they come out to 36? And it suggested ground ball outs. And so I start with the right-handed pitching ground ball outs, and I do the regular thing that I'm doing. and then I add whatever this remainder is. So if it's a minus, it'll subtract 1 with the ground ball outs here. And if it's a plus, it'll add 1. And then that typically will adjust everything. Sometimes you get some low, you'll get a 0 every once in a while or something like that in here. And it'll be like, oh, I can't, that didn't adjust it enough. So then I go to the left-handed ground ball outs. And you can see here I do the same thing for the lefties. And then I adjust that. If I run out of ground ball outs, let's say for a right-handed pitcher, then I'll just go over to the fly ball outs and just automatically adjust it. I don't know if I have any that I had to do that with here, but there might have been a few, maybe 1 or 2 that I had to go through and manually adjust over here. But once those get set and everything says 36, which you can see, then I'm good to go, right? And then I showed it a little bit. You can see this one was way off. So if something is way off like this, I need to like really go through and make sure that all of my stats are right. I've had to go back through and make sure that the actual stats that I'm bringing in, that those things are correct, because sometimes it's thrown things off if I don't have enough plate appearances, or if the stats themselves are wrong. So I worked on that a little bit yesterday to make sure that I get all of the stats coming in the way that I want to, and that helped to smooth things out a little bit. So then I use this formula here, which I talked about at the end of the video, but you couldn't hear. So hopefully you could still hear me. I take this and I put it here on the 11. Now what this does when you put it in there is it goes through this and it splits it out so that each of those results finds itself in a separate column. Now we have an 11 to 66 here, right? So this is from here to here. These are all of the versus right-handed pitching. It would be what's in the red for the batter. So it's all these results here. They make their way to the card if you put them in the same row. And this is Chandler Simpson of the Tampa Bay Devil Rays. Sorry, I call it the Devil Rays. I'm old. The Tampa Bay Rays. So against right-handed pitching, the 11 to 66, these are all the results. And you get that from this chart or this formula here, which splits all of those comma separated strings, and then it transposes them, it sorts them, and then it transposes them again. So basically you create, you split them. So you split all these results. It creates a column. It sorts the column randomly, and then it transposes them again by putting them horizontally. So that's basically what it's doing. And so you get this nice line here, a row, and they're all shuffled together. And then you just do that all the way down for all of the players on the 11, and it gives you all, as long as everything is 36 here, it'll give you 36 results across, and you're good to go. Once all of those are filled out, then you can see here that they are actual results. These are not formulas. Like I told you, I'll put a formula here. There's no formulas because I have to copy these and then paste them as text. Because if I don't, and I leave these formulas here, every time there's a save and I do something, it will reshuffle everything. And obviously, that's fine during production. It doesn't really matter what they turn out to be in production, even if from one card set that you're just testing to another. But as soon as you want to make this a set, you need to get these set into stone, so to speak, so that they never change. So these will never change. They'll just be like they are. I don't really care. I'm not trying to shuffle them into a particular pattern. So if it gets shuffled 32 times, that doesn't really bother me while I'm creating the cards. But as soon as I want to release the set, I want to be able to come back into this and make changes and not have to reshuffle all the cards, if that makes sense. So this game is a little bit more tenuous because I need to really make sure that I have everything right. Because once I set everything, all the results here are based on all of this math. So if all of this math is not right, then the results are not going to be right. So I have to be really conscious of that and make sure that everything is set and exactly the way it needs to be. And then we have our 11 to 66 here. You can see that's for left-handed batters or against left-handed batters. And we do the same process here. And so on the 11, I put the formula. It does everything out to the 66 as long as all of this is 36. And this is 36. It happens just like it's supposed to. All right. This was just to make sure that we have enough pitchers who are the leverage ratings. I think it was looking at the leverage ratings. So, yeah. Oh, it was the base running. I'm sorry. So it's looking at our base running and making sure that we have 5 is the best base runner, 1 is the worst. And so we want this nice like bell curve this way, where most of the people are going to be 2s, 3s, and 4s. That's sort of the top of your bell curve. And then you have very few 5s and you have few 1s. So that just making sure that we stretch those out and make sure that it's a nice bell curve of players. So 37 players have a 5, 131 players have a 1, and then you can see it's whatever 2, 4, about 550 players have 2, 3, or 4. So sort of in the middle. So we want a nice distribution of ratings so that most players are average, right? That's kind of the idea. All right, so that's the pitching, and that's all set. And I'll walk you through that. So now I'm moving on in the chat. So we should tackle the other combat component, which is hitters. Okay, so it's walking me through. This is a little bit of overview from the previous. I just don't know where the now I'm going to be super hyper aware that this is still going. So I'm going to cover over a little bit anyway. So we want to mirror what we did with the pitchers, which is to use K percentage, walk percentage, and home run percentage. This is going to be a 3 outcomes kind of game. But we have also some other types of things going on. So if we look at our batters, you can see here that it's not just 3 outcomes. We have a running rating. We're going to have an arm and catch rating. We have range, errors, and fielding. We do have some different things that can happen on ground balls and line drives and stuff like that. So there will be some baseball feel, and it won't just be about strikeouts and walks. This is merely to determine which card do we get the result off of. Do we get it off the pitcher, or do we get it off the batter? Okay, that's all we're looking for. We just want to know which of these players in this confrontation is going to give us the card we need to look at. So just kind of keep that in your mind. So then we can build the hitter composite this way and give each hitter a score. And it tells me what all everything would kind of point to, I guess, as, skills that the hitter has. We can stabilize it. And in the previous video, I talked about how we stabilize the pitching. We used this column here. That's batters. So we used these things here to sort of stabilize. It was this one here, I believe, that we used. This one here is what we used to sort of normalize or stabilize the pitchers based off of the number of innings pitched or total batter space, something like that. Plate appearances. So total batters faced. So we want to use this 300 plate appearance stabilization for hitters. So that players that only have 214 plate appearances are not treated the same way as somebody has 614 plate appearances, because they're not the same. They didn't play the same amount. One played 3 times as much. And so we're sort of trying to even out the flash in the pan. A guy got 50 at bats. He hit 472. Is he a 472 player? Maybe, but Probably not. So his batting average is probably not going to be 472, but he caught lightning in a bottle for 2 months, and that's where he wound up, right? So we want to sort of flatten out and stabilize those players because we don't actually know if that's the kind of player they are. And I'm not using 3-year averages. Like, there are different things that you can do in a game where you average their career over 3 years, or you take their entire career average and you take that into account. There's different things that you can do to sort of normalize the flash in the pan, but that's essentially what we're doing here. So we're looking at the league average, and we are taking his raw score, and we're sort of comparing that against the league average to bring that down. And it says now both sides are using regression because we did that with the pitchers as well. We set it on a 1 to 5 structure. And then we need to decide the interaction rule. This was originally what I was thinking. If the hitter's a 4 and a pitcher's 2, that's a +2 shift. And the shift moves things. Their direct interaction has an effect on what happens on the play result. So we'll walk through that, and it'll change as we go along. It gives you some different options here. Here's the recommendation for what you should do. Here's something to remember, and then next steps, right? So it's asking me about the interaction. If the D6 roll is greater than the pitcher, the results come off the batter card. If a 5 rated batter subtracts 1 from the pitcher leverage value. If 5 rated, then the batter subtracts 1. So I don't know. It's got personality now. Now we're cooking. So then it reiterates, is this exactly what you're looking for? Let's look at that mathematically. So on a roll of 1 to 6, if the pitcher's leverage is a 3 and the batter controls 50% of the outcomes, right? And the batter will control 2 and the pitcher will control 4 if the pitcher is an average pitcher. So then the batter controls 67% of the time. I don't know how I gets to that. But tell me this, is think about this. Leverage only matters at a 5 rating where you subtract 1. So I was thinking the best hitters should have more advantage, right? That's kind of what we're trying to get at. But then it suggests something else. So if the hitter can have advantage or disadvantage even at 3, 4, and 5, so that the rating always matters. So 1 and 2 hitter has no effect. A 3, 4 subtracts 1, and 5 subtracts 2 off of the pitcher leverage. And again, we're still just rolling the single. You would just do this math in your head. If you have a 5 rated hitter against a 4 rated pitcher, then he subtracts 2 from the pitcher, and so the pitcher effectively becomes a 2. And then anything 1 or 2 on the D6, it goes off the pitcher card. Anything 3 or greater goes off the hitter card. So that's how you get this sort of math here. So 67% of the time, a hitter's going to use his card against a pitcher, even a 4 rated pitcher, which is a really good pitcher. It's telling me this is a strong system. I suggest, what about a 5 and a 4, and then the rest are 0? That would sort of bring things down a little bit for most hitters, because most hitters are not going to be 5s and 4s. So that's going to bring you a little bit closer to the mean or to the medium. And this is the suggestion coming out of that. My initial thought was to just take the pitcher leverage score into account, like Status Pro's PB rating. So you're describing the PB rating concept. It explains to me what that is. Pitcher leverage only, it starts to walk through what this does and how that affects everything, and then it gives me some things to consider. Do you want control to present pitcher dominance, or do you want control to represent the matchup tension? And then it gives me the math of everything. What does it honestly think? So I appreciate that. I said I'll stick with the pitcher leverage only. I want to make sure it's hard to get off of a pitcher's card, and also give poor pitchers a chance to compete against even great hitters. That is what's happening now, but it's it's a more even matchup. So it appreciates that, you know. So then this is what control looks like. How to make it so that it's even harder to not choose the ace pitcher card. I need to get to the batter outcome, so I'm just like trying to move it along here. You mentioned that the math needs to inflate to make sure that the stats come out right. And with this current system, is that still the case? So you need to still need outcome inflation. That's the 50-50 math that we talked about. If you want to learn more about that, you can go to Steve Etzel's Fun and Games, I believe is the name of his channel. Or you can just look up 50/50 math tabletop games. And Steve has some great videos on how to deal with 50/50 math. He has one dedicated video that I'll put in the description here just because I think it's really good to help you understand when you're looking at a card from some of these older games, especially a 50/50 game. If you actually do the math, you're like, whoa, that's super inflated. But it's inflated because the pitchers are like a dead weight pulling down on, you know, so that the batters don't get too high. So you have to inflate one or the other. So you have to deflate the pitchers, you have to inflate the batters so that they will pull each other. There's like a tension between them, and you have to pull them into the right range for that player's stats. So I explained it a little bit more in the other. He goes through this inflation, blah, 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 blah. With the pitchers, we started with home run, Ks, and walks. Then we split out contact percentage into different types of hits. Should we do the same for hitters or different? Should all hitter percentages be driven by splits or just the hit types? And so now we're exploring this, right? Do we do the same structural things that we did as with the pitchers? Yes, but not philosophically. So it's yes, but not. So they control different aspects, so they need different things. But essentially, yes, the answer is yes. So this is where it gets interesting. You have two paths. One is a full split system. One is a partial split system, which is what we went with. So overall home run percentage, K, and walks. So those are going to be sort of the same thing, regardless whether you're looking at left-handed or right-handed pitching. So if we go back to our data combined, you can see all of these slots here are separated out by left and right-handed pitching. These slots are not. These are just your overall home run K and walk percentages. But once we get to the balls in play, those are all split out. So I went with that sort of hybrid system, which was the recommendation, I think. If you split everything, you get the leverage weight and all that. If you split only contact, then you get all of these different things too. So it's much more controlled, but for me, I told them to make it hard to get off the pitcher's card and give poor pitchers a chance to go against great hitters, but the full split home runs fights that goal, and it amplifies the hit or dominance, but the partial split preserves that design intent. So that's sort of helping me to make that decision as well. Here's the final recommendation, which is what we wound up going with. So ground balls, fly balls, and line drives are distributed based off of splits, and then we derive the hit types from those, and then we have home runs, Ks, and walk percentage, which are all the overall. Show me the steps I need to create the hitters from which stats together to the final leverage number. So it's giving me the steps that I need to put together in order to create all of this. So what stats do I need? Lock in the 3 true outcomes. So you need home run, walks, and Ks. You have to calculate the balls in play percentage, which I did right here. So that's the balls in play percentage. It's just 1 minus all of these 3 percentages here. Everything is not a home run, strikeout, or walk. In this video, you're getting kind of an inside look at modern sabermetrics and how people look at each plate outcome. So It goes much finer than this now. This is probably stuff from 10 years ago, but this was sort of in the meat of the sabermetric conversations. It's moved past into StatCast now because there's different types of performance level stats now, not just outcome level stats. So then you want to gather all these stats together. We leave out the unintentional walks. And then we need ground balls, fly balls, and line drives against right and left-handed pitchers. We need to convert those to rates. So this is how you convert into home run, walks, and K percentage. It's just those stats divided by plate appearances. And then balls in play percentage, you can see that's what I did as well. So I just showed you that. So you need to lock in those core outcomes, and then you need to figure out how many slots are for each one. That's this whole process here. And then we begin to do the slots. I've already explained that for the pitcher, so I'm not going to explain that for the batters because it's the same process. Then you need to convert those contact. You allocate the ball in play slots, which is the ball in play slots here. This is essentially the same as, I think I call them contact slots for the pitchers, but it's the same thing. Then once we have that allocated, we use our contact types, and we need to convert those into, using batting average on balls in play, we need to convert those into hits and outs. So it gives me some sample percentages here. I have the actual batting average on balls in play, so I just did that. And then we need to fill the 36 slots, which is what we did here. So we have all of these. We need to make sure there's 36, and then we do all the same thing. In fact, I use the same exact formula that we used over here. I use this as just sort of an all-in-one formula. You just need to change the cell that it's referencing. And I just need to reference CL or CO columns. And then it gives me the shuffled results, right? It takes all these results here, it shuffles them, it sets them out in a row, and that's where we are here. Since you move the hitter influence on leverage, the rating is cosmetic. We later come around to this to be something else. So you mentioned that if the results don't equal 36, I should add it to the ground ball outs. That's what I talked about here, where I had this offset, and then I needed to add numbers over here. So then we talk through that. What if I need to subtract? Should I try to subtract hits? I sometimes find there's more than 36 when I do the automated calculation. So then we walk through that. Never subtract randomly, never just subtract a hit. You need some hierarchy, like do this first and then do this. So that's where I landed on just subtracting from the ground outs. So first I start with the ground ball outs against right-handed pitching, and then I go to the fly ball outs, and then if necessary, I'll do the line drive outs and adjust those. So it doesn't happen very much, but it does happen. So we talked through that, and what's the best way to handle that? I want to create a single batter rating, 1 to 6. For pitchers, I used weighted home runs, walks, and K percentage. Is that enough for batters too? And so it says no, that is not enough for batters, because they do two different things. They have two different approaches. Why does this work for pitchers? And then why is it incomplete for batters? So it doesn't talk about the quality of balls in play. And then what should a hitter rating represent? And then what should be included here? So we have home runs, walks, K percentage, ISO, which is slugging minus average, I believe. Slugging minus average. I think that's right. Or you can use WOBA. And so WOBA against the league is great. I did not wind up using WOBA. I wound up using OPS. So if you want to stay inside your existing framework, then you would use home runs, walks, Ks, and ISO. ISO could be easily configured from what I have. WOBA is cleaner because it takes in all those things already. And so for hitters, use WOBA or OPS plus type of index. These are the values I have to access right now. And then it goes based off of what I have. You have plenty to estimate the total offensive value. Don't need WOBA. We can approximate it. So using the data that we already have, that we can input, I could have just used WOBA because I have access to that over here. But I want this to go back into history, right? I want to be able to use the simplest metrics that I have in order to send this back into history. So it's saying calculate the average OPS, and then you determine each player against the average league OPS, which that's where we start to see this OPS index. We're starting to build this OPS index. And then we need to convert that to a 1 to 5 or a 1 to 6 rating, so that if your OPS index is greater than 1.3, then you get a 6. You would have to go down to, who is this? Is this Nick Kurtz? That's Ozzy Albies. So in the time that he played, his OPS index was a 6. So Nick Kurtz is on here somewhere too, and he also has a 6. There's a few players, Otani, I think, and some others have an OPS index of greater than 1.3. But then if it's in this range, you get a 5, this range, you get a 4, etc. Why does it work? Here's an optional improvement. If you want something closer to WOBA, then you can add in slugging. Use this formula for an offensive score and weight it towards slugging. I did not do that. And then this gives me the final recommendation. So I'm working on getting the position player positions. I moved on. I did that. I put it in the spreadsheet. I'm moving on. Now I'm thinking about getting position player positions. So the data is listed like this. I get this from Baseball Reference. And then I give it, what do all of these symbols mean? So I wrote in what all the symbols mean. Can you show me a formula that's going to evaluate and assign positions for each player? So the positions follow normal baseball positioning. I give it an example. It understands what I'm trying to do, right? And then it reiterates everything. We'll build a formula that extracts the primary position. It ignores pinch hitters. It optionally includes DHs, and it returns a clean positional list. So basically what we need is it's in the fielding, and we're taking the positions here as they are given to you, and then we need to create this position list like this. We need to convert the number to a letter. That's where this is. So it's the formula they're about to give is this formula here. It's a little bit hairy and long. That's why I'm saying ChatGPT. I don't know how to do a formula like that, but ChatGPT can put that formula together in just a couple of seconds. So it gives you like advanced data manipulation, which I think it's one of the great strengths for me and what I'm using here. So we want to take all of these numbers. Let's say this player here, who is that? Abraham Toro. Toro played first base the most. He played third base, so he's a corner infielder. And then after the slash means I think that they have like less than 10 appearances or something like that at these positions. So he also pinch hit, and he also pitched. So these are the positions that he played. For this next guy, he was a second baseman. Adiel Amador was a second baseman, and then he had a few pinch hit appearances. So he needs to become a second baseman. He needs to have first base, third base, and pitcher. And we're ignoring the pinch hitter because you don't need to know. Anybody can be used as a pinch hitter. You don't need to know that. So all you need to do is take this, and we need to split it into a list like this, where it says first base, third base, pitcher. And then once we have this list here where we sort of convert it 1-to-1, then we need to split it out into 3 separate positions so that when I go to the batter card, I can fill in 3 separate spaces here. It was better for me to do it this way. I tried just one long string. It doesn't look as good. So I wanted to give everything a little bit of space here. But you can see Jacob Young only plays 1 position. Michael Garcia played 3. Tyler Freeman played 3. Zach Neto, only a shortstop. Luis Robert Jr., only a center fielder. So that is all based off of their fielding stats. And these are just the general fielding stats that I pulled off of Baseball Reference, right? If you go to Baseball Reference here and you look at the fielding, come on, and you do standard fielding. Wow. That's not what I was looking for. Why did you do that? Look at standard fielding. And then you go down. Every single player here has everything, including their position. You can see the positions here. So whenever you go, all I do is I untick this so that I get everybody. I do share and export, modify. So if there's anything on this table that you don't want, you can click on modify. And then you come through and you can just click the X and it'll get rid of whatever it is, right? Like if you don't want their age, you just click X and it'll remove the age. It's moving a little bit slowly. Maybe it didn't catch. Anyway, click the X. If you want everything up to innings, but you don't want anything else, you can click on this. Yeah, I know it's slow. You can click on this X here and it'll get rid of everything from this point, all of this stuff. So if you don't need any of this stuff back here, I don't know why. Maybe the JavaScript is flipping out. But anyway, I do comma separated list. It's really just maybe because the tab was a little bit wonky. Okay, so just make sure everything is okay. Yeah. So here I am, and I just refreshed the page, put it in a new tab. That tab was sitting overnight and kind of dead, so maybe that was the problem. Whenever I get here, then I click on comma separated. That's what I like to do. I like to do a CSV. You could do any of these different things that you want to. But I like to do a CSV, and then I just copy down all of this data like this. And so it just gives me all of the data that I need down to the very last one. I copy and I paste it into the spreadsheet, and then that's how I get all this. So then I just, I do all the things here and I make sure they look pretty because it just helps me to read everything. So it comes down and it gives you everything to here. Now, everything after this is all formulas, but I have it set so that I can literally just copy any year and then paste it here, and it pastes in everything up to here. And then everything after that is going to be a formula. So all of these things are from somewhere else. Now, I do that because I want to be able to quickly put data in here and just have it spit out these formulas. It'll take everything in these predefined columns, and then it'll look at it. So I'll always be looking at whatever this is, AA12 here. And as long as I continue to pull in the data the same way each time, it'll overwrite that, but this will always be referencing this column. So that will make your creation of formulas and things like that way easier. So just remember, make space for your raw data. All of your calculations should come afterward. That way, once the raw data changes, all of your calculations change. You can put whatever year you want in here for that. Who was the MVP? Aaron Judge. So then we get our position list like this, and then we need to split it out. That's what we're doing next up here in the chat. So it's telling me how it's going to do all this, blah, 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 blah. All right, come on. So this is the formula it's going to use to do that and not include DH. What if there are multiple positions before the slash like this? And then it says, okay, we'll make something that handles that. Sometimes the H or the D shows before the slash. I give more examples of how that could happen. And so it goes back to the drawing board, creates a new formula. And eventually, if you also want DH included, So do you want the player to show a DH as the position? Then whatever. So then, here's another one. Sometimes there's no asterisk before the slot, right? So sometimes it's just a number and then the slot. So it creates a new formula that handles that situation, and then it should take this and output this. And so this, I'm saying, yes, this is what I want. Can you limit the positions to the top 3? So I don't want more than 3 positions, because on my cards, I have just 3 slots, right? So I only have 3 slots here. So I'm limiting that to 3 slots. So it does that. So it's limiting it here to 3. You can see that limitation. Let's count the DH only if it's the left of the slash, but not to the right of the slash. So this one would not be counted, but this one would. So we do that. And then it shows that you can see DH is included here. It tags it on to the end. Why is it bulletproof? I'm telling it here. I covered this in the first video, but it keeps creating a formula that has, he's using, or it is using A2, and I need it to be using AA3. That's the actual cell that I want to reference, right? So it's AA3, right? So this is the one I need to start at. And if what it does is, the longer these formulas get, the more you have to go through each one. You have to put AA3, and so you just don't want to do that. So just correct it, tell it this is what the reference is, and then it begins to build off of that, right? And each time it builds a new version of this, it'll use the appropriate one, which is going to save you some time. So it's like dealing with a 4-year-old sometimes, and because it can't see anything, it doesn't know what you're talking about, right? It's like, okay, I can do that, but I don't have any reference for what is actual, because I'm not looking at your spreadsheet. So it's a bit like computer programming, where you have to tell it, how many degrees it needs to turn left and how many feet it needs to go forward. And I mean, you just have to tell it so many things, because it has zero reference for whatever you're doing. So that's one of the more frustrating parts of this, that a person could look at and deduct and do all these things. You're not dealing with a human. Make sure the DH is included in the 3. There should only be the top 3 positions. Apparently I tried that, and that's not what was happening. I'm getting this error when there's a picture where it says /1, because we get a lot of those, right? We get a lot of these /1s. So I needed to discern a picture. Mine /1 should be a picture, not a DH. So we go back through it. I'm getting a formula parse error, another error. Only the DH works now, and the rest of them are blank. This is a problem. So this is where it starts to spiral out of control. So only the DH works. So whatever it's doing with its formula is cutting off all of the rest of these, so that only the DH works. Now it's catching multiple numbers to the left of the slash. It's not catching multiple numbers, so it's doing everything right except not doing the things to the left. We still get the same. Now only the DH works again. Still only the DH. It's kind of funny to walk back through the conversation, but it was frustrating at the time. Still DH shows. It's still trying to figure it out. And then I finally just get frustrated, and I said, okay, this is the last code that worked. And then it tries to build out what we're trying to talk about using that. Do you want a version that considers numbers after the slash but still respects the top 3? Yes. So it tries to build that. And then I get more errors. More errors. And then at some point, I'm just like, we're running around in circles. You're not creating a solution. So let's start over. So this is how I do it. I just clean the slate, and I say, okay, let's go back from the beginning. Convert all the numbers left of the slash, and so I start to break it down. This is what you have to do in programming anyway sometimes if you get it too complex. You're trying to do like cram a bunch of stuff into one cell or one space. Sometimes you just need to split it out into more simple steps. And so that's what we're doing. So convert all the numbers left of the slash and the first number right of the slash. If there are no numbers left, don't worry about the DH. Just cap the position list at 3. So I give it more simple instructions for it to create what I want it to create. And so you're not converting all the numbers. It should convert all numbers, not just the first one. So still running into a problem. Let's start over again. Don't worry about the numbers right of the slash. Just convert all the numbers to the left and then separate them with a comma, limit it to 3. Right, so then we don't even worry about any of these numbers to the right of the slash. We just do what's left of the slash. It's still only doing the first one. This is a selection of positions played. Is there a formula that will convert at least the first number to a position? So this works. If there's a second number, convert that to a position using a comma between the first and second. So you can see I'm taking it all the way back to, okay, just focus on the first number, get that right. Now there's a second number, put a comma between them. And now I'm encouraging. Yeah, great job. Write a formula that will look at the third number and convert that to a position. So now we're just looking at numbers irrespective of slashes, right? So that it would have 3 positions. So you can see my mind is trying to break this up so that the computer will understand what I'm trying to do. So now this is the intended output. I want to show each player's, so that apparently works, right? So I want to show each player's position on the card, and that's what we're talking about here with the batter card. So I want to show each player's position. And this will show 2 commas even if the player has 1 position. So this is where I was telling you I was trying to just take this list of positions here and output it straight to the card. But if there were only 2 positions listed, it would have this trailing comma here. So I was just trying to get rid of that trailing comma, which it gave me maybe an if then. Yeah, I don't know what it was giving me there, but so we have an interaction between the pitter, and apparently that worked. Then we get the play result off the cards. We need to figure out a simple fielding metric. So now we're talking about fielding and a way to get the position hit to. So where did the ball get hit to? Is there an error? What happens with base runners on? So determining where the ball is hit, we start kind of simple, right, with that kind of stuff. You can weight these things. Here's a simple fielding metric using a defender rating. I haven't told it any ratings that I want to use, so it's just saying generally this is how you would do it. How to do an error check. What do you do with base runners? So it's giving me like more information than I really wanted or needed. Let's start with the direction of the ball. So again, I'm just like, okay, I love all this information you're giving me, but let's start like one at a time to figure this thing out. Can we have a chart for ball direction based on splits? So for a right-handed hitter, you have a 1 to 6 roll that would do these things, left-handed, etc. There's using a basic 1/3, 1/3, 1/3, which is not league average, and that is not, per player for sure. We have whittled that down to something a little bit better. So we're thinking about should pitchers influence direction or not. I don't have pitchers influencing the place that the ball has been hit. Can you show me what all 4? So it's saying, do you want this, 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 or this? And I said, well, what would all 4 look like? So just show me all 4. So 1 is 1 roll, looking at handedness only. That's what you would do here. Here and I'm still working through this part, like even in a chat that I I did somewhere over here, maybe this one. I'm still thinking about, how should we handle hits and where they should go and stuff like that. So we have a spray hitter, extreme pull, balanced, or opposite field hitter. So you have different types of hitters and where the balls would go. And then this is what the chart would look like. A platoon, so versus right versus lefties, what would that look like? And then a status pro outcome plus direction, right? So this is what I've been talking about, because on the last video someone had mentioned it would be great if you just have ground ball and it goes to this player. It presents some very unique challenges because I'm doing splits for ground balls, fly balls, and line drives, and so now that just becomes a challenge. If it was just he's a right-handed hitter, and right-handed hitters generally hit it to shortstop 60% of the time, that becomes easier. So that's why the talk of, okay, a pull hitter, a neutral hitter, an opposite field hitter. I do have those stats. If you look over here in your custom reports, this is a pitcher, so that's not going to work, or it's fielding. But if you look in your custom reports, batted ball stats, we do have pull, center, and opposite field. So we do have those stats that they keep in Fangraphs, at least. I don't know if Baseball Reference holds those or not, but we do have that percentage, and we can break that percentage out into the splits as well. So that's why I love Fangraphs. It's super easy to work with. And it has all of the advanced data that I typically need. So it's given me all of these things to think about. What I'd recommend, D is the cleanest long-term design. I like option D, but I prefer a one-size-fits-all approach that uses splits and handedness. And so that whoever left that message on the last video, you could see I saw it. I flirted with it. In the end, at least at the beginning of the game, I want to do kind of a one-size-fits-all approach. So handedness determines the spray bias. Sorry about that. And platoon split adjusts that bias and a universal direction of the table that applies to everyone. That's what the game has right now. It's elegant, it's scalable, it's realistic. So that's kind of what we went with. So we need all these different things. We need to determine pull, opposite, etc. Convert direction and batted ball type to a position. So on ground balls, if you're a pull hitter, the positions need to be 5 or 6. And if you're an opposite hitter, it needs to be second base and first base for a right-hander, right? So I think we all understand how that works, where righties who are pull hitters are going to pull it to the left side, and it'll be the opposite for a left-handed pull hitter. So what if we have an 11 to 66 chart split by righties and lefties? Is 36 chances enough to cover all the possibilities for fielding? So we could put error and range checks in with some of the results. It's absolutely enough. You don't need to represent every defensive possibility. Some people might argue with that, but it's enough to have a defense check required flag. It tells me why 36 is enough, and then how to structure that. Here's what it would make outcomes like. That's moving a little bit more into the batted ball game that I've been working on. And it's not as explicit. So this will be pretty explicit here, but that's not the way we're going. So this will be a fly ball pulled, range check, and I don't know what the number in parentheses is. So where do errors fit in? Blah, 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 blah. What about keeping the cards as they are now, then adding a second 11 to 66 roll for the defensive play? That way there are only 2 to 3 rolls max. And so we're sort of thinking through gameplay, how this is going to work. The second chart shouldn't determine what kind of ball it is. That came with the first roll. The second chart should tell you all these other things. So then we begin to work on this chart here. So 11 to 66 roll. which gives you, again, a nice bell curve, which maybe that may still be the most elegant solution, is to just roll the 2d6 dice. Right now, I've switched it over to a d20. Is 36 more than enough? Can we get away with a d10 or a d20 instead of rolling and having such a large chart? You can absolutely do a d10 or 20. It shows me what a d10 would look like. That's not enough for me. So here, limited tuning control. That's how I feel about it. A d20 result gives you 5% between each one, and it gives you 20 results. 80% of what the D36 does with simpler dice that you can also roll with the initial 2d6. So that's kind of how we got to that. What do you want? Like, what are you looking for? And then that will help you make a decision. It said the D20 is probably a better thing. And so I'm like, that sounds good to me too. Let's do that. So it builds a D20 result. If we go back to our charts, then you'll see that's what we have here. We have a D20, and then we have all these different things here. Up to 15, you're going to get splits, right and left-handed, and then from 16 to 20, at least on the ground balls, it doesn't matter whether you're right-handed or left-handed. That's going to be just a hard ground single or fielder's choice or foul ball or whatever. Same thing over here. Up to 16, you get split results, so that a foul out for a right-handed batter goes down the first baseline, a foul out for a left-handed batter goes down the third baseline. More than likely, you're going to pop one up to the opposite field like that. And then 17 to 20 gives you sort of these other things. So a pop fly on the infield could go to anybody. That's not really splits-based. So this is what we did. And basically, over time, we've reworked this over and over. It gives me a range system, which also gets included in the game. And so this range check here, we begin to work out the range system. We begin to work out the error system, which also is here with the error check. And the double plays also get worked out in the game here, which this is the entry level, right? And then it gives you a runner sample. It tells you everything that this includes. There are no pitcher and catcher fielding chances, so I asked them to add that in, which we do have pitcher and catcher chances here now. And then I'm just asking it to, what the heck are you talking about up here? Somewhere that is telling me, I was like, okay, like, what do you mean by all these? If this is the double play results. And so it goes through and it walks through like what's actually happening, what's the intention of what's happening on each of these plays. So I really want to know so that I can explain that in the rules. Why are there no auto DPs? It's because defense, speed, and positioning matter. I like that because it gives the individual player some power in the game. I don't like games that only do auto DPs. I do that in on-base baseball. I've done it in some other games as well. Just it's for speed's sake more than anything. But I think for a really good fielding system, there should be a chance at an error. There should be a chance at, your range mattering on every single play. So how do you tie pivot success to the defensive rating? So I'm thinking about on a turn, there's the person catching the ball making the first throw. There's the pivot man who catches it at second base and throws to first. So how do we deal with those things? It's trying to give me some solutions here. Ultimately, I went with fielder fielding the ball. So the fielder's fielding rating, that's this number here. And then the pivot man's fielding rating, and the batter's running rating, and the D20 result. We add all those things together. If it's 1 to 14, then the double play is turned. If it's 15 to 18, there's a force out at second. batter's out at first, and this is really just semantics. If it's 19 or 20, then the runner beats the throw to first. I mean, the same thing happens here. You get the out at second, force out at second, but this is just a narrative thing. So 1 to 14, double plays turn. 15 to 20, it is not. Right, that's a fielder's choice. And then we start talking about error checks. So I want that to be on a 0 to 3 scale, same as everything else. So you can see here that the result, these are on a 0 to 3 scale. The catcher arms are on a 0 to 3 scale. The running is based on a 1 to 5 scale, so 5 is better. But on these fielding ranges, the 3 is the worst and 0 is the best. So this is very similar to Strat and some other games that you would see with the fielding rating. So hopefully that feels like not jarring, but kind of familiar to you. So we're walking through those, how each of those basically, how each of those affects the play, the different kind of player. Add the rating to the player's D20 roll so that the worst fielders trend toward a fielder's choice. That's how it works. So when you add all these things to the D20, let's say you rolled a 12, but all of these other things equal 6. 6 plus 12 is 18, and it forces you this way. So a worse fielder, because we're using the higher numbers, a worse fielder catching the ball and throwing first, a worse pivot man, and a high batter run rating all would result in pushing you toward a fielder's choice. So that's how it works. But if you had a 0 and a 0, so both of these are 0 or 1, and the batter's run rating is a 1, then you don't need as low a D20 result. So that's kind of how it will work. And you can think of the D20 result as the speed at which the ball has been hit. So a slow roller, 1 to 5, you're going to need to have a really good fielder, a really good pivot man, and a really slow runner is going to affect that. So if it's a slow roller, it probably won't matter because if these things are low, then it won't matter. But if it's a hard grounder, like it was hit, it's a 12 or an 11 or 13 or even a 15 is just going to be a hard grounder that you can't do anything with. So that's sort of the idea with how that philosophically works. I guess that should be the way to talk about it. What about a fielding rating 1, 2 plus the D20? So I'm already working out that math. That's a nice way to simulate a good or bad double play pairing. We should use what should we use for the fielding rating? Should be a combination. So at that point, I only had range and catching, which has turned into range and error. And then we created this third fielder rating, and that's what we do here. Basically, fielding rating is range plus catch. We wound up working that out to a different formula. These are the fielding stats that I have from Baseball Reference, and so it starts to use those stats that I have in order to create this rating. 0 should be the best, 3 is the worst. It makes the assumption that 0 is the worst, 3 is the best, so we got to recalculate that. Fielding rating equals range plus catch, and should be put into a 0 to 3 scale. 0 is the best, the best, 3 the worst. So we normalize it again so that we have these things. And then it also makes a suggestion if we want to put the weighting in for second base and shortstop, how would we do that? So now we're weighting, we're putting weight to whether a player is at second base or short. So that takes us back to our fielding. And then we have our range, catch, and fielding here. So you can see this is if we're using these ranges here, if P, so RDRS per year is what we're looking at. So that is defensive runs saved per year. So I guess that's total defensive runs saved. If that is greater than 5, then the player gets a 0. So that is this guy here. Who is that? Aaron Shunk. So Aaron Shunk has a 13, and he gets a 0, right, for his range. For catch, we're using L, and L is errors or fielding percentage. So we're working off fielding percentage. If it's greater than 985, you get a 0. 975 to 985, you get a 1, etc. And then our fielding rating is one that's a little bit hairier. So AJ, so the range plus catch, and then we multiply it by these things, and this is, we do this if there's regex is looking for letters, and it's looking at a regular expression. So if it matches second base or shortstop, basically we divide that by 2. Otherwise, we leave it as it is. So it should be more difficult. You should have a smaller rating for a second baseman or shortstop. So they're generally better fielders and that kind of thing. That's what's being worked out here. What should we be doing next? Okay, we should work on base running. I'll try to get through base running, and then I'll cut this video off, and we'll just have to continue this series. I just only have so much time in the mornings. So let's tackle base running. Here are the stats that we need to think about. Here's a base formula for base running and stolen bases specifically, but basically we're coming out with a running rating. What should we be using? Base running, a raw number, and then we add a caught stealing penalty and some other things talking about that. Do you want me to write a formula that puts base running on a 1 to 6 scale? Yes. So it's using all these things: stolen bases, caught stealing, doubles and triples, and then it comes out and weights those to a particular place. It rewards extra bases, and then it puts it on a 1 to 5 scale. And we use 1 to 5 because that's what we're doing here, right? So we're using, still with me? Okay. We're using a 1 to 5. This is the catcher arm. This is the running rating on this side. And we're using the running rating for the triples check as well. So the higher the run rating, the better the player is going to do. I can also tweak it to penalize bad stolen base percentages or reward triples more. So that's just sort of a thing. Get another error with that formula. Rewrite the formula with these cells. Again, it does the same thing because it doesn't know what I'm referencing. So I'm always having to come back and say, no, you're referencing the wrong thing. Because when it gets to a formula like this, you don't want to go through and redo that every single time. So it rewrites it with the proper cell references. Get another error. Another error. Ready to paste formula. Yeah, let's try that. I went with 2 columns, so we need to figure out a base stealing system. So it was giving me an option for things, and I just went with whatever 2 columns is. So let's create a base stealing system. Running ability, catcher ability, base steal chance. So essentially running ability minus the catcher ability plus a d20 roll. So that it's a pretty simple base stealing system. And then we create a catcher rating. And I told it, okay, these are the things that we have to choose from. So that's in our fielding stats, right? So if we go back to our fielding stats, we have these base runner stats here. And you can see this is a catcher, right? So it only shows for the catchers. That's Adley Rutschman. And then we have that only for the catchers. So these are our catcher ratings for wild pitches, pass balls, stolen bases, caught stealing percentage, and pickoffs. So we use those formulas, or we use those ratings to create a formula. A catcher raw score. And then it's telling me 3 minus caught stealing. Not sure what we went with. So there's an easy to paste formula that we go with. So I paste that in and it does everything that we need to do. You can also add pick into the formula where pickoffs get extra credit. What did we go with? We went with catcher rating here. And you can see this is the end of the catcher rating. So it looks here. No, it looks AF. It looks here. And if this includes a C, which that's all this regex here. So if this includes a C, then we want to do this calculation. If it doesn't include a catcher, like this one or any of these, it doesn't do the calculation. So the formula is there, but it only runs the calculation if there's a C. And then if there's a C, then we sort of go through, we add 3 to this raw catcher score. And so the catcher score adds in all these different things. So this is giving weight to all of these different values here. So we use these values to create a raw catcher score. We look and we only do the calculation on a catcher. We don't need zeros here. They just need to be blank. So we come out with a raw catcher score that is between 1 and 0. Or 0 and 3. I'm sorry. So between 0 and 3. And so we're going through, that's what all this is going. Should start at row 3 and go to 1687. That's the evaluation of this column here, this one, the AF column. It should go all the way down the page. You know, how many rows are there? This is an error, another error. When I input the raw score formula, I get an error. Write a condition that says if C is in column AD. So I'm solving for this problem. So it's a different one. But if it's in AF, if it says C, then run the calculation. Otherwise, leave it blank. So that's what I talked about. Column AD can have 1, 2, or 3 positions. So it has to check for everything. I need a column to normalize that score on a 0 to 3. So that's this column here. So we have a raw score. And was trying to do all the calculations here and spit out a number. So we just went, sometimes it's easier to go with the helper column and just do one formula at a time. So the raw score is in AA, so change that here. In the evaluation formula, looking at the catcher, every raw score is a 2. So now it needs to stretch those out so that there's more differentiation. So now it's only catchers that have a 2. The rating should go from 0 to 3. Again, I need to have it change its reference. It just happens a lot where you just got to catch it and say, I'm not doing all that work. I need you to change it and spit it back out. Can you do a check on this card? So we finally get it doing what we need to do. And so it does a 600 plate appearance simulation versus a 3 pitcher. So now I guess that all worked out well with the I guess that worked out well with the catchers. So now I'm doing it's just doing a mathematical calculation based off of the stats and the all the things that I gave it here. You can see fielding was originally like this. I broke it out into, I've revamped the cards like 10 times. So it's always a continual process. It's always a process of evolving the game. And after you play it, you got to go back. And after you play it, you got to, okay, I need more. I need something here. So it's just like a continual process. And so we do this, and you can see here the results simulated versus a regular pitcher using the formula that we use now, where the batter affects the pitcher. And so you can see that everything is coming. You see the doubles here, 50 doubles, just ridiculous, the number of doubles. And I don't know if he has his actuals, but it was just too much. So compared to the stats on the card, 290, 389, 462. 290, 389, 462. So it comes in kind of low. The OPS is going to be too low. The home runs are probably spot on, but the doubles are way too much. The walks and strikeouts are probably pretty close, but doubles are extremely high. On base is still decent because of the strong walk rate. Remember, we have a basic home run, strikeouts, and walk rate. So that's going to give us our core player attributes. But these other things are kind of, based off. Remember, we were adding doubles in when there's a fly ball result. There are a few of those slots that turn into doubles. And so that's where the extra power was coming. So I said, run it against this actual pitcher card. Now we can have a true batter pitcher outcome. So we start working through that. And he's a switch hitter, so he's hitting left-handed. So that's where it says, we're using his left-handed batting column. So we combine those together. We do a hip breakdown. We scale it to 600 plate appearances. And now Perdomo versus Zach Gallen over 600. You can tell that's way less, but we still get the 50 doubles. We still get the 17 home runs. We still get about the same number of walks and Ks. So the average is way too low. The on base is lower than reality. And so we got to go back and we got to try to start figuring out where this problem is. We do Corbin Carroll against the same pitcher, and over 600 plate appearances. This is his look. I don't know if it shows. Here's his slash line: 259, 343, 541. So you can see it is still quite a bit lower. We still come out with 50 doubles. His home runs are equivalent. I mean, I think he had 31. And then we have walks and strikeouts, right? So average is suppressed. Doubles are extremely high. On base is still a little low. So can you tell what the issue is with the average? Why is it so low? So it goes through and it's trying to tell me mathematically why they are so low and why the average is getting crushed. When you combine the cards, and so you do the interaction between the cards, we're not doing the 50-50 math, I think is what it is. So the true matchup, the batter hit rate is 8. The pitcher allowed is 7. The true matchup should be 8 for the pitcher. And then this is always going to pull everybody to the middle. Again, this is the 50-50 math. This is what it looks like in reality when you don't do it, right? So instead of a 50-50 resolution, you need a batter first engine. So you just only go off the batter card. Or you need some kind of range roll, which shifts the pitcher. Or some kind of weighted solution. Strat avoids the average problem. They give certain dice ranges fully to the batter and certain fully to the pitcher. So you're literally just saying these two don't interact with each other. If you went all the way off the batter card, or if you went all the way off the pitcher card, you would get these results. So sometimes it's here, sometimes it's there. But my 50-50 split with this is just too blunt force. And then just this will be when we come to a resolution, this will be the last thing. So not sure if it makes a difference, but the initial roll is 1d6. Compare that to the pitcher card. If the roll result is less than or equal to the pitcher's leverage number, the result comes off the pitcher card. That's what I'm doing. If it's higher, then the result comes off the batter card. And so now it talks through what that does to everything, why the average is still low, even when you do that. Because, again, it's forcing regression back to the midpoint. It's the 50-50 math solution or issue. There are some hidden average suppression mechanisms that were in there. Walks don't drop as much because it just doesn't collapse as hard as batting average does because you're changing outs, right? I mean, or you're changing hits, but not changing outs quite as quickly. And then it shows you an example. This is what that compression effect looks like. Why the 3 rated pitchers are too strong. And then the real question is, this. So it provides a fix. And then we need to redesign the leverage scaling entirely. Your current system is linear. It's every move is a 1 out of 6 chance step up. And so we need to really rethink this. So we decide the true control range. How often does a pitcher dictate the at bat? And so we kind of walk through the numbers there. These are the real numbers of when they would control the at bat, and these are the numbers that we were using. So it was a little bit too heavy-handed. And so he's trying to create a better system using a D10. This is a preferred model for this. Using dynamic leverage would help. So for a 2-rated pitcher on a 1 or 2, a 3-rated pitcher a 1 to 3. When the pitcher he only modifies the extreme results. So if the pitcher card says ground out, but the batter rolled a home run, the pitcher downgrades the home run to a double. So it's you see this sometimes in card games where it's there's a I can't think of a game, but maybe replay. I can't remember. There are some games where you roll off the batter card and a situation comes up, and then the pitcher can modify that situation and turn a home run to a ground ball. I've used the same thing in a systems before, where you just say, oh, the strength of this pitcher turns this into that. That's how on-base baseball works, where normally without that pitcher influence, it would be X. But because of the pitcher influence, it's Y. So that's why this happens. So you get a little inside look at some of your favorite games and why they do that. I don't personally love that because it's okay in this situation where a home run goes to a double because maybe the quality of the pitch means they don't hit the barrel of the bat. But sometimes it's like a home run turns to a ground ball or it turns to a pop out, which sometimes those are okay. I mean, sometimes it makes sense. It just, as long as it makes sense to me, I'm okay with that. But if it doesn't make any sense, I really have a problem with it. But basically, you're simulating the ball not hitting the barrel of the bat because the pitcher is good, right? That's kind of what we're simulating. But it also helps the math. So it gives me an extra thing. How does Status Pro handle this? So then it walks through how Status Pro does all this. You get your breakdown here on the 1 to 9, right, or the 2 to 9 number. And so it's saying the way you're doing it is not as fine-grained as the way the PB number works there. So it's non-linear because it's using 2d6s, not 1d6. So then it starts talking about, okay, 2d6 probabilities are smoother and they're not quite as big a jump. That's why it can work. This is why it doesn't kill the average, because a 5 or a 6 is not 50%. It's more like 28 to 42% that the pitchers control. So an average pitcher doesn't control half of the at-bats. An average pitcher only controls about a third of the at-bats. So it's just showing me how it's built based on, compared to what you do. So if you want to mirror that, here's how you can do it. Recalculate it under a 2d6 control model. So we have more of a weighted distribution like you have with the PB rating. You're still getting numbers that are depressed, but you can see that the averages, these things are starting to creep up just a little bit. So that's telling us that we're moving in the right direction, right? Run Perdomo. Perdomo, same thing. Under the simulation, let's see, it doesn't give me. He still has too many doubles. And then it starts talking about the real splits. So we're getting, somewhere there, the average is still depressed a little bit. what if we use what we talked about? A 5 leverage batter reduces the pitcher -2, 4 -1, and then does that do anything to make things different? Okay, so it's saying, okay, this is getting us going in the right direction. So it tells me what percentage of the at-bats are going to be controlled by each batter, based off of this, 5-4 system. Big hitters now see more of their own card results, and weak hitters they go to the pitcher. So league average is stabilizing. And can I still use the 1d6 model if I include batter leverage? So this is where you start to make a turn into batter leverage, as it is now. So right now we're using 5 and 4 to subtract 2 and subtract 1 from the pitcher leverage, still using a 1d6 model, and then it shows me the numbers where that would be. So that's this one here. It does work. I can recalculate it. So I said yes, recalculate those. And then here we start to get a little bit closer to the numbers that we should be getting to. Batting average much closer to the 290. It was at 230 something before for Corbin Carroll. He's at 249, 905 OPS, 30 home runs. So this is a lot better than what we were doing. Can you show 2d6 plus the batter leverage adjustment? Goes through the math and shows me scaled. You get basically the same thing. Carroll and Gallon. So adding batter leverage to the 2d6 favors the batter, preserves average and on base, and then compared to that, it smooths out the bell curve just a little bit. So do you want me to what? Let's see. Create a table showing all of the different ways that we've thought about the game engine, right? So it has each of these. So scaled to 600 plate appearances, just the D6, D6 plus leverage, just the 2D6 or 2D6 plus leverage. You see that things come out a little bit better, closer to OPS when we're using with the leverage. So these others are a little bit suppressed. So the two leverage ones are better. So when we look here, we see the same thing. We see them coming out a little bit closer when we have the leverage than when we don't. So this is the flat, this with the leverage, flat, leverage. So we're moving towards something, right? I like the D6 with the leverage. I can still use the cards and the calculations that I have right now. So there's no need to redesign anything. I want to stress test this with some other players. Eugenio Suarez. And compared to his raw stats, he batted 189 overall. He had a 231 average here. 25 homers was probably spot on. 42 doubles is way too much. And then I explained how I do it in precision baseball. And then this is where we start to get to where we were, where we are now. So this was the turn toward how it is set up now. So there's some advantage to the system. Of course there is. That's why I did it with the other game. So let's do this with that type of setup. It runs it on a scale of 600 plate appearances. High leverage hitters get a big boost in average and on base, so those are closer to their actuals. This is Suarez. Remember, he hit 183, so he's getting even a little bit closer there, and he was pretty close on OPS. Low average leverage hitters are slightly favored, so it's close but not there. Can this be used with the 1 to 6 player leverages instead of a D20 system? And so again, we're still getting closer to where we were. What's the formula to do a comparison for each at bat? Not exactly sure what I was asking here, but am I overthinking it, right? Can I just compare the batter and pitcher? Roll 1d6 against the player that wins the comparison, a tie goes to the batter. So I feel like I'm doing flip-flops. Just pull out the gun and shoot them, right? That's like the old Indiana Jones thing where the guy's doing all the fancy knife work and then he just pulls out a gun and shoots them. Sometimes you're just overthinking it, right? You just need to take the simple solution. And this is the final, right? So higher number wins the at-bat. A tie goes to the batter. You could also make it go to the pitcher if you want to, however you want to do that. If you want to suppress offense a little bit, you can do that. So that is roll out some plate appearances with Josh Naylor against Zach Gallen using this same comparison system. And then giving us 600 plate appearances. It does all that. What's the raw out? Oh, okay, because he didn't have 600 plate appearances. So what? Okay, I did 600 plate appearances for him. And then I realized somewhere along here, what about if I just did the 394 that he actually got? Can you, like, so that we can do an apples to apples comparison of his? And so it breaks down all the different hits, contact against, correct approach, use the card reported stats. So you can see these are the ones here. I don't know if it does it's almost exactly what his card came out to be. Like these numbers here are almost exactly what Josh Naylor's stuff was. So we want to simulate Gallen's card over his true number of innings. And so we did the same thing. We come out over 192 innings pitched with almost exactly the same numbers that he had as well. So the player cards are spot on. And so that I'll leave it at that because I just wanted to get through how we got to the leverage roll at this point, but that's what all that stuff was. You can see it's just like a lot of back and forth and, hey, here's a suggestion. Let's try it and let's see if that fixes the problem. Okay, so it's getting us closer to the issue and fixing the issue. So that's what we're going to do. We're going to keep like edging ourselves closer to it until we get to a mechanic that's the right thing to do. So then we wind up where we are, and we're sort of defining that interaction rule here. And then what's the easiest way to do this to avoid the 50-50 adjustments and just keep the numbers how they are there. And so we continue with the leverage talk, and I just want to see it work. So we do all the simulations again. Can you remake this? Okay, then we get into something else. What are we getting into? We're getting into the range checks at this point, so I'll stop there. But you can see we're about a little more than halfway through the conversation, and that's how we get to all of those numbers. So I'll leave it there. If you have any questions or comments, leave them down in the comment section. If you like this video, just give it a thumbs up. And if this is an interesting series, just let me know in the comments. If you have any questions about what I'm talking about, or you want to see something slowed down, you can let me know and we can go back through it. Or a lot of this is just kind of working things out. It's not necessarily something you need to see, but I'm just trying to show you like how the interaction with the AI works and how the prompts work, and moving through each of the phases of creating the game. If you want to join the Facebook group, go to Facebook groups and answer a few questions, agree to the group rules, and I'll be happy to let you in. And if you haven't clicked subscribe, you should click subscribe That way you'll be notified of new videos when they're posted. Typically 1 or 2 a week is what I average. And so you can be the first to know when new videos come up. You'll see those on the app or on the desktop application, the website. Whenever you go, it'll be in your subscriptions tab. So if you want to keep up with everything we're doing, not just this series, but the games that I'm building and any games that I'm playing. So we'll continue to make our way through. This is part 2 of however many, maybe 3 or 4. I thought I could get through it in 2, but I can see it's a lot, right? A lot of stuff going on, and hopefully it helps you to understand how you can use, if you're a designer, how you can use ChatGPT or any generative AI to be able to work together to create and ideate and test and all the different things. So this is essentially a really smart math partner that I have that can do a lot of testing for me. So that's it's been a real gift to be able to do that and to make more complex and subtle and deep games. So hopefully you all are seeing you are seeing my games get better just because I'm taking this approach, and they're getting more sophisticated as we go along and able to do more on the tabletop with fewer components, smaller footprints, better math, more accurate results, that type of thing, and some interesting interactions that maybe weren't possible before without having an advanced math degree, which I do not have that. So it's kind of cool, and let me know if you have any questions about it. I'll be looking for this later on down the road. Maybe this weekend I can get back into this and continue part 3, but hopefully you have a lot to chew on with parts 1 and 2. All right, I think that's it from here. Thanks for watching, and I'll see you again next time.